We're going to graph problem 1. It's a radical equation. We're going to do this using an input-output table. So we'll choose values for x, input those into the equation, and find out what our output is, what our y is. First, I'm going to go ahead. Let's choose 0, always my favorite. So that means we're going to go ahead and put 0 wherever there's an x. So we're going to go ahead and do that. I'm going to write my work over here. So I've got f of 0 equals the square root of 0. We know the square root of 0 equals 0. So when we put a 0 in for x, our output is a 0. We put that into the table. Now I'm going to choose 1 for my x. So I'm going to have f of 1 equals the square root of 1. And we know that the square root of 1 is 1. So when we put a 1 in for x, we're getting a 1 out for y. Let's see what happens if we put 2 in. I'm going to put 2 in. F of 2 would equal the square root of 2. A lot of us don't really know what the square root of 2 is, and it's not something we want to graph. So let's get rid of 2. Let's just go ahead. When we're doing these, when we have an x under the radical, let's choose values so that under our radical, we'll always have perfect squares. Under a radical, we want perfect squares. So let's see, that was 0, 1. I know, let's undo that. I know that 4 is a perfect square, so I'm going to use 4. And 9, 16, and 25. Those are all perfect squares, so I know that they're going to work nice when I put them in there. So f of 4 equals the square root of 4. The square root of 4 is 2. So when I put a 4 in for x, I get a 2 for y. Let's go for f of 9. That's the square root of 9. We know the square root of 9 is 3. So when we put a 9 in for x, we get a 3 for y. Let's do f 16. That means this is square root of 16. We know the square root of 16 is 4, so we can put a 4 in there. And lastly, for this table, f of 25, the square root of 25, which equals 5. Okay, so now we have a bunch of points here in our table that we can graph. When I first graph the point 0, 0, it's right there. Then graph the point 1, 1. Then the point 1, 2, 3, 4, 2. Then the point 9, 3. All right, 25, 5 won't fit on this graph. So, nor will 16, 4. So we're going to go ahead and connect our points. Now, if we were trying to use a line, if you can see, there's not a line that's going to hit all of my points. That's like the closest you can get, but that still doesn't really go through all my points. The reason for that is when you graph radical equations, they aren't lines. They're kind of these curves like that. You get the idea? Let me try it one more time. Curves like that. And that's what that graph looks like. Now to continue on with the problems at the bottom, I want to go ahead and take a look at this one. If f of x equals 9, what is the value of x? Okay, so we're going to go ahead and just find that out. So f of x equals 9. We know that means the square root of x equals 9. So the square root of x has to equal 9. How do we deal with the square root, getting rid of that square root? What you're going to do to undo a square root is square both sides. So you're going to square both sides of your equation, because squaring a square root, they kind of cancel each other out. They're the inverse, so they undo each other. So I'm getting x equals 9 squared, which is 81. So the value of x is 81. And you can always check that. See if that's true. Does f of x, let's undo that, sorry. Does f of 81 give us that value of 9? Well, it's the square root of 81. Yep, that's a value of 9. So we checked it and it works. Check. Okay, let's go on to this next one. What is f of 9? I like this question right now because we already did it. We did that up here. We already found f of 9 when we were doing that table right there. So we found that f of 9 equals 3. So we didn't have to do anything extra for that one. Domain, remember that's all of your possible x's. So a lot of times we had just start at the left, go along your x-axis until you hit your smallest value. Our smallest value is 0, so we know it's going to start at 0. And where our x is going to stop? They're going to go on to infinity. So we wrote that. as 0 to infinity. And it's the hard bracket by the 0, and then the infinity gets that soft parentheses. Same thing with the range. We go along the y-axis, go from the bottom up till you hit, okay, it looks like it's starting at 0, and where's our y eventually going to stop? It's eventually going to go on forever. So that's also going to have a range of 0 to infinity. We do it that way because you always want your smallest value first and then your largest possible value. Now, instead of going on to problem 2, because problem 2 is an exponential function, I want to quickly take a look at problem 3 of your worksheet. So that's another one with a square root with a radical. This time you're adding 1 to it. You're going to start that the same way. Values for x's, since x is under that square root sign, I want to pick values for x that are going to be perfect squares. I want to make sure that the stuff under my radical is a perfect square. That's going to make it easier to graph. So let's pick some values like 0, 1, 4, 9, 16, and 25. You're going to like those numbers a lot if x is the only thing under your radical. When other things are under your radical, you're going to need to pick different numbers so that everything under your radical is a perfect square. All right, so let's do some of these. If f of 0 is going to equal the square root of 0 plus 1, square root of 0 is 0, so our output, our y, is going to be 1. Now let's go for f when x is 1. F of 1 equals the square root of 1 plus 1. Well, the square root of 1 is 1. Plus 1 gives us a 2. So when we put a 1 in for x, we get a 2 out. And you're going to go on and do this. So f of 4 equals the square root of 4 plus 1. So that's 2 plus 1 equals a 3. And let's do that last one. F of 9 equals the square root of 9 plus 1. Square root of 9 is 3. Plus 1 equals 4. So when we put a 9 in, we get a 4. And you can finish the table on those others. So if we take a look at this, let's graph those points. 0, 1. That point is about right there. 1, 2. Okay, these points aren't in the right spot. I got to try again. It's driving me crazy. Okay. There we go. So that was 0, 1. There's 1, 2. And then the point 1, 2, 3, 4. 1, 2, 3 is right there. And then we've got the point 9, 1, 2, 3, 4, right there. Okay. So one of the reasons I want to make sure we do this one is take a look at this graph compared to the one that we did in number 1. What happened to it? How is it different than problem 1? And how is it the same? All right, go ahead and continue those as you work with those radical equations. Let your teacher know if you have any questions. Thank you. And don't forget to be awesome.